Hey everybody, welcome to the Asian edition of my weekly live stream. Hopefully, anything new on the shelf? Yes, there is something new on the shelf. So I am kind of sick of streaming services. And so I've been kind of returning to physical media in the last couple of weeks. So the first thing that I did is I went and I bought a DVD player, which I don't have a PlayStation. I don't have an Xbox One or whatever it is. So I actually bought a physical DVD player and Blu-ray. And then I've been hitting up thrift stores and picking up Blu-rays and also taking out a ton of movies from the library. And our library is so good. It's just got this fantastic selection of movies and nobody takes them out. And so I go in there and there's just, I take out 10 movies at a time, bring them home for the week. My wife and I just watch a bunch of these movies and we've just been crushing my cinema backlog. And so I feel, and then I'm like, I might buy some Blu-rays and DVDs, and so I've been picking up movies. So I got a bunch of stuff. Oh, hi guys! It's like it's my haul from my media haul. This is what I just bought. So I got a copy of Minority Report, which I enjoyed. I got Django Unchained, which is a great movie. I got Planet Earth 2. And I got Planet Earth 1. There you go. Attenborough in the house. And then I got the new Star Trek movie. And I got Gladiator. And I got Master and Commander, The Far Side of the World. And I got the first Lord of the Rings movie. And I got Inception. And I got Dark Knight. So those are all like, I made a list of my favorite movies and those are all on the list. So I'm being very, very careful. I don't want to collect like a ton, but I do want to have like the movies that I really love. And so I can just watch them when I want to watch them and not have to like chase them down to chase them down to whichever streaming services has them, or they don't have them on the streaming services or whatever. So, and I was like doing the math and we probably spend, I don't know, like $120 a month on streaming services when you add up Crave and, Crave's a Canadian version of HBO. And then of course Netflix and Disney Plus and Prime and, there's another one. Anyway, and so now I'm like, man, that would be like, I could buy 15 movies a month-ish, right? If I just pick them up at thrift stores and stuff. And then also all these movies that I'm taking out from the library. So we're just kind of trying this out for size and see about whether or not we'll just cut our streaming services and just go to physical media, which is super weird for me because I was the first person to ditch my physical media, and now I'm having to rebuild my collection. So here we are. Yeah. So, I was out watching the Comet tonight. So Comet, Lemon, 2026 Lemon is visible and it's in Booties or it's in Serpens now. And you can see it with your eyes. So you walk outside and in dark skies, and you're able to see it off to the west after the sun goes down. And then I hooked up my two telescopes, and one, the Sea Star, was able to find it right away, and I was able to start observing. The Vespera doesn't have it in a database, and so I had to go and find the location, and it wasn't playing nicely, and so I wasn't able to take pictures of it with the Vespera. So I continue to test these smart telescopes, but it's pretty cool. And you can see we looked at it with binoculars, which of course is super fast, right? You put up the binoculars, oh, there it is, and then my wife comes out, I give her the binoculars, it's up from that tree, and she looks, oh yeah, I see it. I'm cold. I'm going back to bed, going back inside. So, but yeah, so right now, if you are thinking about looking for the comet, now is the time. Right. So, yes, I am recording. So for those of you who are wondering what it is that you have stumbled into, this is our weekly live question show where you give me your questions about space and or astronomy. I see that Zapvan is in the house, so we'll be able to grab your questions and categorize them for the system. And then I will be able to go through the questions and answer them here. Now, a few ground rules, of course. First thing is that I try to give emphasis to the people who've never had a question answered before. So if you've never had a question answered, I like your chances. The second thing is that I am just a journalist. I'm not a scientist. I kind of provide you any additional information above and beyond the scientific consensus. It's important to know our limits. And my limit is, I am well read on what people think. I do not have any original thoughts. And then the third thing is that, we get a lot of the same questions, and I'm sure we're going to get a whole bunch more Comet Atlas questions this week, and we'll see. I may answer them, I may not. And like last week, I think I was really trying to resist ranting about the comet and about the pseudoscience and about the YouTube AI slop nonsense. We'll see. I may continue to try, or I may just give in, and hopefully Anton and Chad won't choose those. Like, guys, let's not do more Atlas stuff on the channel. But yeah, I'm at your mercy. Okay. All right. So yeah. So we get a lot of the same questions. So I just want to remind you that, if your question's one that we're getting a ton of, I will sort of may skip it. All right. Let's get into it. Get an answer because I don't know this answer directly off the top of my head. Okay. Rob H. Is it true that we don't know the distance of Polaris from Earth? And if so, what does this mean for our use of Cepheid variables? Does it cast doubt on the use of standard candles? We know the distance to Polaris. It is 446.5 light years plus or minus 1 light year. So the uncertainty to that measurement is about 1.1 light years. So it could be a little bit closer or a little bit farther, but it's pretty close. And Polaris is just one Cepheid variable that astronomers measure. They are aware of thousands and thousands of them. And originally, the distances to the Cepheid variables were measured very roughly and very carefully using the astrometry method. So you measure the angle in the sky to Polaris or any other Cepheid variable or any star really when the Earth is on one side of the sun, and then you wait 6 months for the Earth to be on the other side of the sun, and then you measure its angle in the sky again, and then you're watching to see how the star moves against the background of all of the other stars. And so over the course of the year, you're going to see the star kind of bounce back and forth. And the example that I always use, right, is hold your thumb out at arm's length and then just open up one eye, close the other eye, back and forth, and you'll see your thumb jump back and forth in your field of view. And so that's what the astrometry method does. The parallax method is that you're able to measure the distance to the star because it creates a triangle, and you're able to measure that using trigonometry. And the parallax method kind of has its limits. We can only measure out a few thousand light years away. It depends on the brightness of the star. Dimmer stars, it's not so easy. Very, very bright stars, you can measure them farther out. And so astronomers had measured a whole bunch, the distance to a bunch of these Cepheid variable stars. And then they were able to track the pulsation of those variable stars, use that to calculate the intrinsic brightness, use that to realize that you're really just, when you're watching the pulsations of these stars, you're able to know how bright they are. And then you just measure how bright you see it. And that allows you to calculate how bright it is. And that allows you to tell how far away it is. And that's the method that they use to calculate the distance ladder. And because it is the first rung on the distance ladder, it is the most important rung. And so astronomers put a lot of emphasis into measuring the, checking and double checking and remeasuring and making sure that their measurements to the Cepheid variables are still correct. And so every few years, we'll see a new science paper where, some astronomer has gone and redone the calculations and confirmed that they are, yes, indeed, still correct. And of course, we got the Gaia mission, which came out from the European Space Agency a few years ago, which was like the most comprehensive measurement of astrometry, the parallax method, for like 1 billion plus stars in the Milky Way. And so we've learned a tremendous amount about the structure of the Milky Way, the distance to stars, the movements of stars, thanks to the Gaia mission, which is doing this astrometry parallax method at a vast scale. So we know the distance to Polaris, we know the distance to thousands of other Cepheid variables. We check them, double check them, and use that as that first rung on the distance ladder to measure the distance to other things in the universe. Borg terraformers. Have humans found any other planets as habitable as Mars? I wonder if they do not realize how fortunate a gift they have right in their own backyard. So, all right. So have we found any planets? I guess you're saying any exoplanets as habitable as Mars. And the answer is actually no, because, we have found planets with a lot of characteristics that are interesting and potentially habitable, but there's still a few pieces that have not been found yet. So, imagine sort of like your perfect analog to the Earth. You've got an Earth-sized world that is orbiting around a sun-like star, and it is located within the habitable zone of that star. So liquid water can appear on its surface, and that planet has an atmosphere. That would be the dream. That would be the ideal. Now, we've got little bits and pieces of those. So astronomers have found Earth-sized worlds orbiting around red dwarf stars within the habitable zone. They've found super-Earth planets orbiting around red dwarf stars and maybe sunish-like stars. I don't even think so. They've been able to detect the presence of the atmospheres of giant planets, but they haven't been able to detect the presence of the atmosphere around Earth-sized worlds, around sun-like stars, or even around red dwarf stars yet, within the habitable zone. Have they detected around hot ones? Yeah. So right now we're still waiting to be able to actually detect an Earth-sized world orbiting around a sun-like star. We're still waiting to detect the presence of an atmosphere, even on an Earth-sized world that is orbiting around an M dwarf or a sun-like star. So Mars, we know it has an atmosphere. So it is already vastly more habitable than anything astronomers have ever found. But I don't think astronomers are thinking that it's going to be the most habitable world we will ever find. There are a lot of stars out there, and astronomers are finding a lot of planets. And so you can expect that, this is not that these things don't exist. This is just that the tools have not been developed to the point that they're capable of resolving and confirming that these things exist. So Mars is okay, right? It's not great. It's got a bunch of things going for it, and then it's got a bunch of things that are going against it. So like, what does it have going for it? It has a solid surface that you can walk around on. It has dirt, not really dirt. It has regolith, crushed up rock, things on its surface. Its day length is about the same length of time as Earth. So just a little over 24 hours. It has an axial tilt, so it has seasons like the Earth. It has an atmosphere, but a very, very thin atmosphere. And that's about it. And then the things that it doesn't have is it doesn't have liquid water on its surface. It doesn't have a thick atmosphere in the way that Venus has a thick atmosphere, or even Titan has a thick atmosphere. It has it's 1%. It doesn't have any internal dynamo. It doesn't have plate tectonics, and so has no protection from radiation. So it's the top layer of the regolith is filled with toxic perchlorates. So the top layer is poison to plants. It receives about a quarter of the sunlight that you would get on Earth. So in other words, if you set up solar panels on Mars, you'd have to set up 4 times as much solar panels to be able to receive the same amount of electricity. And so it's going to be very difficult to gather a lot of electricity on the surface of Mars. So, there are a bunch of downsides, but it's better than nothing. I actually think the gift that we have is the moon. The moon, we have this large object that is only about 400,000 kilometers away from us. We have like a surprisingly large moon compared to the size of the Earth. It has regolith. It is, it's tidally locked to us, so we can put a station on the surface of the moon and we can be able to communicate with it directly. We can go into lava tubes on the surface of it. We can be protected from the radiation. And that it can then serve. We know that there are reserves of water ice on the surface of the moon that we can use to mine, to build propellant and have oxygen for astronauts and so on. So it is this incredible gift that is right beside us. And so, for me, I think that we need to learn to really get to use the moon before we try to do any kind of long-term presence on Mars. Like, obviously, put some boots on the ground on Mars, but there's a lot of lessons to be learned about living long-term in space that the moon can teach us. I didn't even mention the gravity on Mars. The gravity is a third, which is, we don't know if that's viable for long-term living. And we don't even know if the moon at 1/6. But if we can survive on the moon, then we can survive on Mars. So, Mars is fine. Mars is acceptable, but it's not great. The universe could have done better. Venus is better if it had not as thick an atmosphere. But, we get what we get. We have to work with what we've got. Dad a monk. Could we ever reach a point technologically where we could add fuel to the sun to prevent it from expanding into a red giant and extend the habitability of Earth? The problem with adding fuel to the sun is that we would actually make it live for a shorter period of time. The more massive a star is, the shorter its lifetime is. And so you want to do the opposite. You want to extract material away from the sun. You want to take away its mass, and then that will sort of counterintuitively, right? It will make it last longer. Like if we had the kind of technology to actually refuel the sun, what we would probably want to do is turn the sun into 13 stars. So we would use a technique called stellar lifting. So we would draw material off of the sun. You could use, powerful magnetic fields, or maybe you could spin up the sun and you could extract material off of it, and then you would collect it over into a smaller star. And you just keep doing that until you had 13 red dwarf stars. And maybe you put them in some kind of orbit where they're all orbiting one another. And now each one of those is going to live for 10 trillion years. And that's better. Like, that really gives you some time to hang out So no. Now the other thing is if we had a way to mix up the interior of the star. So the problem with the sun is that it's got the center, the core, which is where the fusion is happening. And then outside of that, the temperature and the pressure isn't high enough. So fusion can't happen, but also you don't get convection. So you have this whole big region called the radiative zone. And it is this firewall to the convective zone, which is the outer part of the sun, where you have these sort of blobs of material that rise and fall inside the sun, carrying the heat out and releasing them to space. And when you look at the surface of the sun and you see these granules on the surface of the sun, these are the tops of these columns of bubbling material that are coming up from the radiative zone all the way to the surface. And it's mixing, but it can't reach the core because of the radiative zone. While with a red dwarf star, they are fully convective. So the whole star is bubbling and convecting, and it's using up all of its fuel, while the sun is only going to use up the fuel in its core, and then it's going to die. And that's only about like a third of its size. So there's tons more fuel that the sun could use. So if you want to save the sun, you just want to bring a big spoon, and occasionally you want to just mix it. Mix up the sun. You can get fresh material into the core. It can continue fusing, and then you can extend the life of the sun. But the best way to do it is to tear it up, 13 pieces, 13 stars, 10 trillion years. Wacky G, is the cosmic microwave background for the entire universe, or do we only see the part that corresponds to the observable universe? I mean, we have no way to know what is outside the observable universe, but, you know, one of the main parts of astronomy is that whatever we see in our local universe is kind of the same for the rest of the universe. And so this idea of the cosmic microwave background radiation, this is a moment of time that was experienced by the entire universe about 380,000 years after the Big Bang, when the universe had cooled down and the universe was opaque and the universe was transparent for the first time, that light could finally reach space. And then this light of last scattering was sent out into the universe and has been traveling ever since. And so when we look out into space and we see the cosmic microwave background radiation, it is this sphere that we see around us where the light has been traveling for 13.8 billion years, you know, essentially the age of the universe minus 380,000 years to reach our detectors. And then 1 minute later, the sphere is a little bit bigger, and now the light has been traveling for 3.8 million years plus 1 minute. And then you wait another 10,000 years and the sphere is bigger. And in fact, if I looked up into space and I could see the cosmic microwave background radiation, I would see one version of the observable universe. And if you were on another part of the planet and you looked up into space, you would see a different view to the observable universe. You would see a different cosmic microwave background radiation, right? Because we are separated by thousands of kilometers. And so different photons are being released at different times, different parts of space. And so no matter where you could go into the universe, you would see a different observable universe. You would see a different cosmic microwave background radiation. You were seeing the places that were sort of throwing out that light that long ago. DarthX03, why 13? So the longest lived red dwarf star is 7.5% the mass of the Earth. And so if you multiply 7.5 by 13, you should get 100. I forget, I did that math a long time ago, but that's why. Stratton Henson, where is 3i Atlas? It is behind the sun. So we are recording this on October the 26th, and it makes its closest approach to the sun on October 29th. And then, at some point in early November, it should pop out the other side of the sun, and we'll continue to watch it. And then it makes its closest approach to Earth in December. So, it's going to get better and better and better as it gets closer and closer to the Earth. We're going to have much better views of it. So the best is yet to come. Driving a Dune Part 1, Part 2. Yeah, those are on my list. I just need them to show up at a thrift store. Or I'll break down and buy the DVDs. Although I'll probably buy the 4K Blu-rays for those movies, because I do have a 4K Blu-ray player, but they don't have them at the thrift stores, or I haven't seen them at garage sales and stuff. But eventually I'll buy some 4Ks for the stuff that I think really deserves it. Alan Works. What's stopping us from using Starship to build an interplanetary research ship? Well, there's like two parts to this question, right? Like, what is to stop us from using Starship to do anything? And that's because Starship doesn't work yet. So, what's to stop us from using Starship to launch Starlink satellites? It doesn't work yet. What's to stop us from using Starship to go to the moon? It doesn't work yet. So, that's the main problem of any mission that you might assign to Starship, is that it is not a complete spacecraft yet. It is not able to fulfill its task yet. But, hopefully they'll iron out all of the problems. They'll get the version 3 of Starship rolling. They'll have the new version of the Raptor engines. They'll be able to test launch this thing, ideally retrieve it back from space, but obviously, it's not necessary if you want to send it out into space and not have it come back, although you will want to refuel it. So, that is the key issue. But let's say that we are some hypothetical number of years in the future and Starship worked and it's a fully reusable two-stage rocket system. Then can we use it as a satellite to go to other worlds within the solar system? Absolutely, right? Or we use it as a really heavy launch system to be able to send a satellite. So, right now, when you look at the shape of a rocket, it has the has the nose cone, and it's got the fairing, and inside is whatever is the payload. And then the rocket launches, and then the fairing comes off, and then the payload is released. It may have a kick stage, and then it accelerates it towards its target. So it might be that what makes the most sense is for Starship to launch some, when you open up the fairing on Starship, inside there is your satellite, your science packages, and then there is a kick stage. And so Starship gets it up into orbit, opens up the bay doors, releases the payload fires its engines and heads off towards wherever it's going, and then Starship returns to Earth and grabs another satellite and heads off to space again. So then you're not having to give up your Starships. But there was a mission idea that we reported on Universe Today last week about how you could send it to Uranus. That if you could, this is one of the big dreams of the astronomical community, to be able to send a mission to Uranus. And the problem is always that it's just so far away, that you're looking at, 10 years, 15 years to be able to send a rocket mission to Uranus. But Starship, if you can refuel it in orbit, now it's got a ton of propellant. It can do a really hard burn and can decelerate itself again. And it can do one other thing that's really cool, which is that it has this heat absorbing surface on it, that it's designed to return from orbit. And so you could use it to aerobrake in Uranus or Neptune, or Venus even, really. Like any world that has an atmosphere, you can fly the spacecraft, you can fly Starship in and just skim the surface of Uranus. And then that would slow it down enough to capture it in orbit around the planet. And then it could open up the bay doors and release a bunch of satellites on different orbits if it wanted to. So, let's get past the first problem, which is that it's not ready. And then hopefully people will come up with really clever ideas on how to use this platform to be able to do science. Okay. 1031 Productions LLC. Since 3i Atlas has been behind the sun, has been hit with a few CMEs, do you think they'll use this to explain how the Joker spun around and is now headed to Earth? Lol. Do you say lol or do you say laugh out loud or do you just laugh? I never know what to do. It's not going to spin around and head towards the Earth. Obviously, it is going to be following the trajectory that it has been following so far, which is precisely predicted by the laws of gravity. And so it is going to return, it is going to pop out on the far side of the sun in exactly where it will be, where it was predicted to go, where it was predicted to come out. But people have done the math and they know where it's going to go. That it is a 5 kilometer across, chunk of ice and rock. It has millions, billions, trillions of tons. It is the mass of a mountain. And so it is going to be following, it's mass of a mountain. It is going 58 kilometers per second. I forget what its speed is at perihelion, like 70 kilometers per second. It's really fast. It is faster than anything we've ever been able to send in the solar system. And so we'll just keep going. Just going to keep going, following that trail, and then it's going to head out of the solar system. It will fade away, and then we will never see it again. The unknown. Fraser, please say the cheap but good binoculars for night sky viewing again. I promise to write it down this time. Okay, you ready? So the Celestron Skymaster. And I like the 15 by 70. So Celestron Skymaster. And so you can typically buy them for about $100. They make a bigger version. They make a 25 by 100. And I've been tempted to pick those up because I love the Skymaster. Like I use them tonight to look at the comet. I use them all the time. But I would resist because they're much bigger and much heavier. So the 15 by 70 is like this nice balance. It gets you a good view to the sky, but they're not so big and heavy that your arms get tired when you're looking at things. WC03. We need to figure out how to lower the probability of doom before we start thinking about colonizing other rocks. I think, this idea of use P doom, right? The probability of doom, but really that's, the probability of artificial intelligence rising up and wiping us all out. And this is an existential threat that humanity is facing right now. And hopefully we will get our act together and we will, pause our development of advanced artificial intelligence. Hopefully, we won't have any sort of scary disasters happen before we realize that this is a risky and very bad behavior. But, I mean, we're doing all kinds of other things at the same time. Only a small group of companies are recklessly thrashing forward with artificial intelligence. The rest of us are doing other stuff. And so, like, let's keep exploring the solar system. Let's keep investing in the stock market. Let's keep raising our children, right? Like, there's all this stuff. Life goes on, and hopefully wiser heads will prevail, and we will reduce the risk of that existential threat and other existential threats. So we can walk and chew gum at the same time. So let's keep exploring. Let's keep doing science. Motasar Ali, will the weekly space hangouts ever make a comeback? Wah, wah. No, they will not make a comeback. The weekly space hangouts were wonderful. I really enjoyed them. That we had a sort of, we had a fairly large group of about 20 space journalists, and we coordinated behind the scenes to bring 3 or 4 of them on every week. So we got this great diverse voices. It was a chance to give young people new in their career a way to be able to communicate with a wide audience, to be able to practice their science communication skills. There was a chance, another place for us to be able to interview scientists, astronomers. Some of the best interviews that we did were in the weekly space hangout. And we ran it for, 10 years or so. And it was great. I really enjoyed it. It was one of my favorite things to host. And unfortunately, it was just really hard to do. We had Nancy Graziano, who was like really enjoyed it and helped coordinate all the people behind the scenes, but it was sort of volunteer effort on her part. I didn't ever got paid for it. None of the journalists ever got paid for it. And the audience, there was a group of diehard audience that really enjoyed it, but we never really got a very big audience from it. And so it was never, it sort of like wasn't able to justify the amount of energy and effort that we put into it. Now, that said, I've sort of reformulated the pieces of the weekly space hangout that I consider to be the most important. So if you look at what I do on the channel, I do collaborations with other journalists here on the channel, not as often as the weekly space hangout, but I do them. I interview people about their research. And if you notice, I put a lot of emphasis on people who are new in their careers. Like, I really like to talk to the people who've just gotten their PhDs, who, maybe don't have a lot of experience in doing communication with the public, because this is it's a safe space. I try to be able to provide that. And then, so through that, and then of course the news. So we do Space Bites on the channel, which is a way for me to be able to communicate all the news that is happening this week. And so a lot of the strongest elements that we had from the weekly space hangout are there in this, and it works fairly well, and it's sustainable, and it's a way that we can continue going forward. So unfortunately, although I loved the weekly space hangout, it will never be coming back. CRP, if you built a Dyson sphere, would it throw CRP? If you built a Dyson sphere, would it not throw off the gravity and the way the planets interact with each other in the solar system? Well, good news. To build your Dyson sphere, you have torn apart all of the planets, and so there are no planets. You don't have to worry about the interactions with the planets because the planets are gone. You tore them up to build your Dyson sphere. Roka, never say never. Sure, I'll never say never. If uh, if a production company contacts me and has a producer who's willing to manage the thing and is willing to pay for it and pay salaries to all of the people who are involved in it, I will do my part. I will be glad to resurrect the Weekly Space Hangout. But if the only way that it can return is through the volunteer labor of lots of people in what is a very kind of difficult format to organize. It's like herding cats. And the audience isn't that really responsive, and most people kind of avoid it. It just doesn't feel like it isn't right. So, like, I know for some people it was exactly what they wanted. They love the camaraderie. They love the to see their favorite people every week. That was all awesome. So yeah, unfortunately. So I'm waiting for, if you're that, Netflix, if you want to run the Weekly Space Hangout, give me a call. But bring money and lots of it. Man. This Aussie says, how many comets with sunward tails have you seen? It's not a normal comet by any stretch of the imagination. So when comets are really far away from the sun, when they've been discovered very early on in their orbit, then you get the sublimation of material. Essentially, you get a heating on the side of the comet that is facing the sun. And that causes causes jets of material to start to blast material off into space. Now, this comet is not close enough to the sun that the solar wind is starting to pick up the material in its coma and stretch it away from the comet. And so what you get is, if you imagine like a laser is heating up the surface of a ball of ice, right? The sun is the laser and it's heating up the ball of ice. Then the material is going to sublimate off of the surface of the comet and just kind of drift off into space. And so the comet is moving along, the sun is there, right? It's heating it up, and you get this just material that is, just starting to percolate off the surface of the comet. And that starts to go into orbit around the comet, and that gets you the coma. And the comet is turning, but, whichever is the part that is facing the sun, you're going to get this additional material. And this is not an unusual thing. This is not unknown. It's not never been seen before. And then over time, as it gets closer to the star, as it gets closer to the sun, then the solar wind picks up and you start to see the material streaming away from the comet, which is exactly what they saw with 3I Atlas. You can see the pictures from the Gemini telescope. You're seeing this tail. When it flew past Mars and it was seen by the ExoMars mission, it had a tail exactly like what you would expect. And I can't give you a 100% guarantee, but I will give you a 99.999% guarantee that when it pops out the other side of the sun, it'll have a tail. It'll be facing away from the sun. And then it will continue on until it sort of goes past the Earth in December and then goes past Jupiter in January, and then fades away and heads off into the cosmos. Brendan O'Donnell, relating to fast space travel, what are the fastest current methods for travel and what are some that are just okay? I didn't see the rest of that question. All right, let's do the first part. Brendan O'Donnell, what are the fastest current methods for travel? So the fastest, there's different propulsion systems that we currently use that have different advantages. So the traditional chemical rocket system can give you very high acceleration. It can take you from 0 to very fast in just a few minutes of time. But then it's over. It's you have to have hundreds of thousands of tons of fuel in some cases, a million tons of fuel, like a lot of fuel, and it's gone in just a short period of time because you are burning this stuff up. It is blasting hot gases out of the back of the rocket, and away you go. Now, the method that we have that would allow a spacecraft to reach its highest speed is probably an ion drive. So in this case, you have a magnetic field and you're accelerating just single ions of some inert material, or you have a magnetic field and you are accelerating ions out the back of that field. So something like xenon or krypton, and you can accelerate them at hundreds of kilometers per second, and that can raise the velocity of your spacecraft. Now, it takes a long time to speed up your spacecraft. The amount of force that the spacecraft receives is kind of like, hold a piece of paper on your hand. That's the amount of force, the gravitational force pulling down the gravitational force pulling down a piece of paper. That is not very much. And yet you just keep that going for months, even years, and it will provide a huge amount of change in your velocity. So it's very efficient, but it's not very powerful. And that's it. Those are the two methods. I mean, the third method that's being maybe kind of tested out right now are solar sails. But really, we're just in the initial testing stages of solar sails. So that's it. You've got chemical rockets, you've got ion engines. Those are the only two practical propulsion methods that anybody's used. Now, I could rattle off a list of another dozen ideas for potential future propulsion systems. But right now, all we have are chemical rockets and ion engines. Is the explosion of satellite mega constellations and space debris making near-Earth orbit dangerously unsustainable? Not yet, but it is not moving in the right direction. So space is really big, and so there is a lot of room for a lot of stuff. But over time, the more material that you have in orbit, the more that stuff is going to collide with each other, and you're going to get that debris colliding with other debris, and eventually you're just going to get more and more debris that's in the region. For the place where the satellite mega constellations are going, it's not as big of a risk as you might think, and that is because they don't last very long. So there are, and I forget the numbers now, it's hundreds, maybe even thousands of Starlink satellites are deorbiting every year because they are, they've run out of propellant and they're re-entering the Earth's atmosphere and they're burning up. And so even if there was debris, it would clean up in a very short period of time. Like within about 5 to 10 years, any satellites that are in that area get cleaned up. And so if the satellite mega constellation stopped launching and nobody was able to continue to boost up their satellites, within about 10 years, that area would be clear of satellites. There would be no satellites anymore. And so if we get to this place where people are like, oh no, we've got too many satellites, then people stop launching them for a while, a bunch re-enter the Earth's atmosphere, the area starts to clear up, and then you've got room to launch satellites again. It's the higher altitudes where it's a bigger problem. So, say below 500 kilometers altitude, like where the International Space Station flies, that region cleans itself up within a very short period of time. Once you get up to 800 kilometers, which is being considered for some satellite mega constellations. So OneWeb flies at that higher altitude. Those will last a couple of decades. And then once you get above 1,000 kilometers, now you're looking at, a century. Once you get above 1,200, 1,300, then you're looking at multiple centuries. And if you get higher than that, then things are going to practically last forever. And so the bigger risk is not where the satellite mega constellations are going. The biggest risk is the higher altitudes, because they just don't get cleaned up. But at the same time, those regions are bigger, and so there's more space for it. And so I think people are really worried that we're going to fall into this Kessler syndrome, where one day we're going to wake up and too many satellites have crashed into each other, and now there's just this metal shell around the Earth that you just can't launch anything new. And it's not going to feel like that. It's that right now, satellites have to make several course corrections every year. That, someone is tracking all of the pieces of space debris, all of the satellites that are orbiting around the Earth right now, and all of the satellite companies are watching the trajectories of everything else that's out there. And if something looks like it's going to be uncomfortably close within the next day or so, they'll fire the propulsion on their satellite and they'll shift its orbit so that it misses, so it gives you more room, more space. And that uses up the propellant on the spacecraft. And so the more stuff that's up there, the more of these random possible interactions that are going to be happening, the more you burn through your propellant, and the more quickly you're out of propellant, and then your satellite will be sucked back down into the Earth's atmosphere. And the right solution is for the world to come together and to agree on where we put satellites. That, if we're going to have satellites, they're going to be observing this part of the Earth, they go in this direction, they move at this speed, at this height, and then we go this way for another one. The way that we have flight paths, or the way that we have directions that cargo ships travel in the ocean, that, instead of it just being a free-for-all with cargo ships crashing into each other, think about highways, right? Like, instead of people just like go ahead, just use the highway however you want, right? No, you stay on one side of the highway, and that minimizes the chance of there being a collision. And so we need to move to this future where the satellite operators are held to very specific orbits. And that will mean that we can then put a lot of satellites and not worry about them crashing into each other. But we want to be really cautious about anybody using those higher orbits, because that's where they don't go away. They stick around for a very long time. Whoa. Ramzi Zetterine, how important do you think it is that we find a way to live off-world? I know we'll never have a better home than Earth, but to preserve life, shouldn't we be focused on living in space? I don't think it's very urgent for us to learn to live off-world. We're not technologically advanced enough today, and we don't have the infrastructure today to be able to make a good time of it. So I think it's right now we're in the let's explore phase of this process. We're not in the let's move to Mars. We're in the let's explore Mars. We're not in the let's move to the moon. We're in the let's explore the moon. In the same way that we're in the let's explore Antarctica phase of our sort of interaction with Antarctica. Who knows? Maybe in the future we'll build cities in Antarctica, that our technology will get very advanced. And the analogy that I always use is Arizona, right? Phoenix. Phoenix is a hot place. It was never designed to have, it was never able to support large amounts of people. And now we have 5 billion people living in the city of Phoenix. And that's because we have technology, that we mastered air conditioning and transportation and being able to bring water in from far away. We can survive in a place like Phoenix, but we have not got that same infrastructure on a place like Mars or on the moon. We can barely, 12 people have set foot on the moon. That is the extent of our ability to explore the moon, let alone live on the moon or live on Mars. And so, obviously we all grew up and were excited by it, thanks to science fiction, about humanity's future in space. And, I think that our future across the solar system is inevitable, that we will one day be living across this solar system, or our descendants or our robot overlords, who knows? But it won't be soon. And I think for a lot of people, you're like, this is going to happen in my lifetime, right? Right? And yet I'm sure there's some people here who are watching. I brought this up before. You were there for the moon landings. I was born right at the end of the moon landings, so I don't remember them. But for those of you who are currently in your 60s, 70s, you watch the moon landing. You're like, this is it. We are going to live that 2001 future. We are going to live on the moon. We're going to live on Mars. That this is just the beginning of our bold future in space. And then nobody did anything for 50 years. And you were disappointed. And now you're like, maybe it's not going to happen in my lifetime. And I think that, we'll know that we're ready to live, like to properly live on other worlds or even just in space in our, once the infrastructure has started to come together. And that won't happen until after the exploration has properly begun. And we're looking at decades of exploration, maybe a century of exploration before we've built up enough infrastructure, before it starts to make sense for us to try and have a longer term existence on other places. So, I think whatever problems we face on Earth, we have to solve them here on Earth. That no matter how bad we make the Earth, no matter how much we ruin the environment for ourselves, it is still dramatically better than any other place in the solar system, right? Nothing. There's, the best Mars we could possibly make after 10,000 years of terraforming would be terrible compared to Antarctica. So we have to really come to grips with the reality that we're going to live here on our planet for a very long time. And yet, I always sound like I'm a doomer here, but we will inevitably be living across the solar system. Within a few hundred years, we will have conquered the entire place. It's just a time frame thing. True crony. Does the lunar Earth system have enough mass to create tidal flexing friction heat as Jupiter and its moons do? I don't know how much heat is deposited into the Earth or the moon through the tidal interactions. And I wonder if it requires multiple moons in the way, like, is it Jupiter and Io, or is it the interaction between Jupiter, Io, and Europa? Like, clearly we don't have volcanoes across the Earth thanks to the tidal flexing. But that said, when the moon is directly overhead, the ground is lifting up by a couple of meters, that you are literally being pulled towards the moon, the surface of the Earth. And there's this like ripple of material that is being pulled up as the moon is orbiting around, and a little bit because of the sun, but doesn't appear to be enough to like cause volcanoes on either the Earth or the moon. Gregory File. Fraser, my feed is so full of this 3i Atlas talk, I need a grounded, educated touch on it. Do you still think that 3i Atlas is a comet? If so, could you elaborate? So 2 weeks ago, we released a 30-minute long video where I went through every single major paper that has been released on Comet 3i Atlas. And so did you see that video? Because that was my best shot at this thing is a comet, by going right back to the original sources and in this case, I was reporting on the work of hundreds of astronomers, dozens of observatories, space telescopes, missions. The astronomical community thinks it's a comet. There's a very small group of people led by Avi Loeb mostly, who are saying that it is possibly not a comet and something else. But they're not offering any evidence that says that it is doing anything that a comet can't do. It's just circumstantial evidence. Like, isn't it weird that it is going to go kind of close to Mars and kind of close to the sun and kind of close to Earth and kind of close to Jupiter? Then only a spacecraft could do that. Well, like a comet could do that, right? Isn't it weird that it's 5 degrees off of the angle of the plane of the ecliptic? Only a spacecraft can do, a comet could do that. So, it has to do something that a comet can't do. It hasn't done any of that right now. And, and I think I've mentioned this before, like Avi Loeb is the gold star. He is the gold standard. He is doing the sort of the most rigorous scientific job of jumping to a unsubstantiated conclusion than out there, right? He is citing his sources. He is writing science papers. They are showing up on archive. And so he's doing his level best to cherry pick evidence to sort of meet the conclusion that he is trying to promote. And the scientific community disagrees with him. And, and my job is to report on the scientific consensus. But then there's this whole entire cottage industry of people who are just making stuff up from whole cloth. Like they are just, it stopped behind the sun. It's beaming transmissions. It's broken apart into 5 pieces, like all of this stuff. And literally they're not doing science. They're not observing it with their eyeballs. They're just making stuff up because then you can release a bunch of this stuff and you can get people to watch it and you can make money from it. That's it. That's what they're doing. And so you're going to have to find scientific sources. You're going to have to find reputable sources that you can trust. And I know it's more fun to say that it's an alien spacecraft. Wouldn't that be cool? Why I gotta be so close-minded, man? Because, I want it to be aliens more than anybody. But I want to know with evidence. I want to know for sure. I don't want to just live in my, with copium and hope and dream, and then it goes away, and then wait for the next one. Everybody freaks out at it again. We all get excited that it's aliens. No, that is not productive. So, it is the most important question that we can possibly ask. Are we alone in the universe? But I want to know the answer. I want to know the real answer, the right answer, the correct answer. I don't want to know the answer when I've got a vague hint and then I just shut down my mind and not listen to any other evidence. No. So, yes, it's still a comet. Yes, it's always been a comet. It's still a comet. It's going to continue to be a comet until it leaves the solar system. And then we're going to find 10 more of these every year, thanks to Vera Rubin. And then you will be bored. We will be all bored of interstellar objects in the way that we're bored of comets, in the way that we're bored of asteroids. We're bored of asteroids. We're not bored of comets because comets can still look cool in the sky. And speaking of comets, go out and take a look at Comet Lemon. No. Not NEC 202. Avi Loeb never said 3i Atlas was aliens. He, in a recent blog post, put it to be a 30 to 40% chance that it is an alien spacecraft. So when you take all of the possible things that it could be, right? If you line them all up, and I could probably rattle off a dozen things that it could be, right? It could be a comet. It could be an asteroid. It could be an Oort cloud comet and not an interstellar object. Could have received a big boost. It could be something more exotic. It could be a primordial black hole. It could be a chunk of a rogue planet. It could be, the moon. It could be a moon that was kicked into a funny orbit from Uranus or maybe from Planet 9. So, we could list dozens and dozens of things that it could be. And then one of those things could be an alien spacecraft. And so if you line up all of those things, and then you put your percentages beside each one of those things, the thing that you've put the highest percentage to is the thing that you think is most likely. Right? And so that is what you're saying. That is what you're saying it is most likely to be. If you hear a sound, you hear a loud bang, and you're like, what's that sound? And you're like, I'm going to say that's a 40% chance of it being a car backfiring. It's a 20% chance of it being a gunshot. It's a 10% chance of someone slamming the door really loudly. It's a 5% chance of there being a movie in another room where someone is slamming a door, and you just go through this big list. And so then your friend goes, okay, so you're saying that you believe it is most likely to be a car backfiring. And you say, yes. Right? Yeah, you didn't cross 50%. You didn't think it was certainly that thing, but it was the most likely thing that you are saying. And that's what he's saying. So people keep saying, you never said it was a spacecraft. Like he is saying he's saying it is most likely that of all of the possible things that he can imagine it might be, the one that is number one in his list is the alien spacecraft. Which is perfectly fine, right? He can make those assertions if he wants. And he, quotes his sources, and he communicates his results to the scientific community in archive, and has raised money to be able to go on missions to try and find meteorites at the bottom of the ocean, right? So, like, more power to him. But, I think you only get to cry wolf a certain number of times before people stop listening. And so that's the price that he's paid is he's lost his credibility with the scientific community, which is unfortunate because he was one of the scientists that I had the most respect for, right? Like, it was awesome. I've interviewed him several times on the channel. Really creative, out of the box thinker, was releasing really cool papers about really great ideas. And as a senior astronomer at Harvard, has a tremendous amount of influence and an ability to sort of set policy for helping to uncover, some of these more out there ideas, perfectly positioned to search for techno signatures and to be able to encourage that. And that's not what he's doing, which is unfortunate. Snazzy Shoes. Will Earth's orbit take us anywhere near the 3i Atlas tail remnants? It is 3i Atlas episode again, isn't it? No, we're going to be about 2 astronomical units away from the tail. That said, 2 of our spacecraft, maybe 3, are going to get very close to the tail and maybe even fly through the tail. So we will get some observations of the tail from within from some of those spacecraft. The Hera mission, the Europa Clipper, and the JUICE mission are all well positioned to analyze the tail. The Europa Clipper is probably the best of these, and so it's got the right scientific instruments on board to be able to examine the tail, and we'll be able to, determine some of the chemistry of the tail and be able to trace that back to, be able to learn more about the star system that this thing formed. Because again, like, the wondrous thing about 3i Atlas is that it formed in another star system that, when you look at the raw material that we have to work with here in the solar system, all of the meteorites, all of the asteroids, all of the comets, they all started with the same chemical soup. There are variations, but they rhyme. And so, every time we find a new meteorite, oh, what do you know? It's 4.6 billion years old. Oh, what do you know? It's made of roughly the same kinds of chemicals. Oh, it's got the same kinds of amino acids, right? When we look at comets, we detect the presence of, slightly different ratios of carbon dioxide to carbon monoxide to water to nickel to iron to cyanide. Like all these things are present. And yet now we've got something that came from somewhere else, formed billions of years before the sun, and is giving us a hint into the earlier universe and a place that is very unlike the solar system. And this is a wonderful opportunity for us to be able to understand just a little piece of what other star systems are like. Quest Dion, has anyone seen Carl Sagan's Cosmos? Absolutely. We did I don't know if they're still doing it, but Twitch was playing Cosmos on repeat for a while there. And so we did a live commentary on Cosmos, and I brought in an astronomer for each episode, and we talked about the new discoveries and our understandings about the universe, sort of an update on Cosmos. It was a lot of fun. Rusty, thinking of moon mining and exploration, what would a Tsar Bomba do to the moon? So the Tsar Bomba, that was a sort of giant uh, thermonuclear weapon designed by the Soviets. I think it was only tested once. What was it? 20 megatons, um, which was a lot. But the moon is hit by asteroids all the time, and they do more than 20 megatons of energy when they hit the surface of the moon. So I don't know exactly, like I could probably do the math and come up with the size of the asteroid that would hit the moon and do release 20 megatons of energy, but it's not very big. So, because they're going very fast. So this kind of thing happens on the moon on a regular basis. So you would see a bright flash on the moon, and then that would be it. Not even a bright flash. Like you would see this little flash, this little part that was like a little bit bright, and then it would fade away. Robert Gavir, which would be easier to make habitable for humans, Mars or Venus? Ugh, they both suck. Um, so if you wanted to make Mars habitable, you would release a bunch of chlorofluorocarbons into the atmosphere of Mars, which would raise the temperature. That would eventually melt the carbon dioxide trapped in the poles, which would thicken the atmosphere. That would raise the temperature a little bit more. Then you would melt all of the water at the poles of Mars and whatever's trapped underneath the regolith. And so you would have a blue Mars. And then, the conditions would probably be to the point that you could put very hardy life, cyanobacteria, things like that, onto Mars. And you would be able to start to have life growing. And maybe after about 10,000 years, you would have a thick enough atmosphere to be able to breathe on Mars, maybe. So that would be the way to go down Mars. But it would still be like really cold. It would be like the dry deserts of Antarctica on its best day. Venus is even harder. You would have to block all of the sunlight falling on Venus from the sun, and then the planet would cool down. Its carbon dioxide atmosphere would freeze out and fall like snow into these layers kilometers deep, and then you would need to deposit some kind of material onto the surface of Venus that would then lock up all of that carbon. So, we think about limestone, calcium carbonates. You need calcium or maybe magnesium. So you would need to find a couple of asteroids. You need to grind them up. An asteroid with a lot of magnesium in it. You have to grind it up and release that material down onto the surface of Venus, lock up all of that carbon dioxide, and then remove your shade and heat, let the planet warm up again. But now it doesn't have like as thick an atmosphere as it did before. And so that would get you a more habitable planet. I think in the end, like if you had to pick one, I would pick Venus every time because it has the same gravity as Earth, and that's a big deal because then it can hold on to its atmosphere. It receives a lot more sunlight than the Earth does, and so then you could have your solar panels would be more effective on Venus than they are even on Earth. So I think if you had to pick one, I'd pick Venus. But that's also mega engineering, way beyond our ability. Oh, 50 megatons. Okay. So why don't you go into ChatGPT and ask it to calculate an asteroid hitting the moon that would release 50 megatons of energy. And that'll tell you the size of the asteroid. I'm going to guess it is 50 meters. That's just my guess. Dylan Callahan, how close will other star systems get to ours? They can get relatively close. Within every million years or so, a star system probably comes within, say, a quarter of a light year. So there's the next one is like 1.3 million years. Gliese, 7 something. I forget the exact number. 714 or something. So it's another star system that's going to come within about 0.25 light years of the sun. So this happens, when you think about, if that happens every million years, imagine how close they've come in the billions and billions of years that the sun has been around. And yet, none have come so close that they've significantly disrupted the orbits of the planet. So you'd have to get much, much closer to actually start to disrupt things. So they can get close. And this is sort of like been thought of as a really cool idea for how you might be able to jump from star system to star system. So instead of creating interstellar spacecraft that will take you 10,000 years to go to another star system, wait until a star is getting very, very close, and then you just hop over. Why is Gliese pronounced Gliese? It's a German word. There you go. ChatGPT said a few hundred meters. So I'm in the ballpark. Take that, ChatGPT. Not NEC 202. Why won't NASA and China release the data? Release the data, NASA. Why won't you release the data? NASA has released the data that they have. So, and in fact, the European Space Agency has, and China, I don't think has any data. So, the data that the data that I'm sure you're talking about is, why don't we have the data from the Mars Reconnaissance Orbiter? And the problem is that the US government is shut down right now, and that all of the people who are working with the Mars Reconnaissance Orbiter were sent home and told to not touch their email, to not do any work. If you do any work, then you are in violation of the furlough and you could be fired when you get back. And it appears the current administration is really eager to fire people right now. And so people are being incredibly cautious. But we got images from the European Space Agency because they're not shut down right now. They're still operating. And so they have 2 spacecraft that were able to attempt observations of the comet. The ExoMars mission, which is normally looking at the atmosphere of Mars, but it was able to make long exposures of the comet and was able to see the tail of the comet. And then the Mars Express mission, which was not able to resolve the comet, but it is only able to make like half-second, 2-second exposures, like very short exposures. So it just wasn't able to do a long enough exposure to be able to image anything. The Chinese don't have any spacecraft at Mars. Their Tianwen is wrapped up. I don't know about the orbiter, but they just haven't released it. If they took any pictures, which I'm not even sure they did. None of the spacecraft at Mars are really designed to observe comets 30 million kilometers away. The best things that we have to be able to observe comets are the telescopes we have here on Earth: the Hubble Space Telescope, James Webb, and then the ground-based observatories. And they've all done their pictures. And now we're waiting for the comet to appear on the other side of the sun, and then they will all take more pictures because there's many, many new things to discover about this comet. So in about 2 weeks, you will be deluged in new pictures of 3I Atlas from all of the space telescopes that we have. And middle of December, it's going to make its closest approach to the Earth, be about 2 astronomical units away. It'll still have a tail, and that'll be the very best time. We will get the absolute best pictures of this object as it is passing. So just like hang tough, be patient. Don't listen to the people who are just making stuff up on the internet. Karen 156, paid leave or unpaid? It's unpaid leave. They are furloughed. They are sent home without pay. So a bunch of people who work in the U.S. government are now showing up at food banks because they can't afford food. Darren Green, do you have a favorite sci-fi concept? I kind of do, actually. And I sort of can't, I don't know what the term for this is, but if you've played the Mass Effect series and you've got the idea of the Reapers, that there is this primordial, ancient precursor species that is an existential threat to the survival of the universe. They sort of cover that again in Alistair Reynolds' books, the Revelation Space series. I really enjoyed that. They cover that in the Culture series. So I really enjoy this idea of, it's like space opera, foundation, this vast scale, and that there's this kind of existential threat from something older and malevolent. I kind of really enjoy those kinds of stories. So yeah, I'd say that's my favorite. Mass Effect Revelation Space is my favorite. Darth XO Tiamat. So that's from Your Name, I think. We just watched the movie tonight. Speaking of physical media. Good old cosmic horror. Yeah. Modus Alley, how would you react to 3I Atlas changing course and starts heading towards the Earth? I would be shocked and amazed and would be quite excited because that would mean that it is in fact probably a spacecraft. That would be amazing. Can you imagine how wonderful that would be if we could see that there was a spacecraft heading our way? Now, obviously, it would be a little unnerving. You're like, whoa, why is it coming our way? But we would get confirmation that we're not alone in the universe. And so would that be worth it? The annihilation of humanity in exchange for an answer to the question, are we alone in the universe? Don't make me choose. Nick Cunningham. Fraser, are you tired of everyone asking 100th Ray Atlas questions? No, like, so the thing is like, obviously I need to stop getting baited by the people who are reacting to the nonsense videos that are on the internet. Right. Like that's the, because like someone's like, it broke up and it's now in 4 pieces that are moving together. It has stopped and has turned direction. But people are watching that. And then they're like, was that real? Right? And like the person just made it up. And then, and it is accepting no responsibility for freaking people out just so they can make a buck. And that's really frustrating. And so I feel like I have to jump in and help. I have to help dissuade people from this sort of perspective that has been inflicted upon them. And so, I would love to answer just more just general, genuine, like if we hadn't gone down this, it's an alien spacecraft rabbit hole, then there would be I would still be getting tons of 3i Alice questions. They would just be legitimate questions based on real science that people want more nuanced answers about. That would be the best. That would be my dream situation, as opposed to having to put out fires where people are getting excited by nonsense. So, yeah. And we'll see you tomorrow, Nick. All right. What time is it now? 11:30? Okay. I've cherry picked out all the new people. So I'm going to go back up to the top now. Owen Bowen, does quantum entanglement mean that the universe is spiritual in nature? No. Quantum entanglement is just one of the behaviors of the universe. It's a thing that it does. And, it's weird and no one expected it. And yet this is the way that the universe behaves. It doesn't mean anything about spirituality. It just means that there's various rules about quantum mechanics that appear to have consequences in our world. And we can use that for our technology even. That one. Stratton Henson, how do we know for sure that space rocks can't collide at such speed that one shatters and bounces backwards as if they were pool balls on a pool table? We see asteroids that have been the result of collisions. So the OSIRIS-REx mission sent the OSIRIS, let me do this again. Sorry, Chad. All right. We've seen plenty of examples of what happens to asteroids after the result of a collision. So, there was the OSIRIS-REx mission. We went to visit asteroid Bennu. And then there was the Hayabusa 2 mission. We went to see asteroid Ryugu. And both of those are rubble piles. They are just a pile of rocks that is sort of loosely accumulated together. And so what happened? Well, 2 asteroids smashed into each other, or larger asteroids, and then the debris collected together into this sort of collection of rocks, of boulders. And so no, if you have 2 asteroids that are crashing into each other, they are going to just shatter each other and create just debris, little bits and pieces. And then depending on the direction that debris is moving, if it's moving together, then it will recombine from gravity, and now you just get this ball of rocks. And so that's the result that we see. We've seen enough of these rubble piles that, this is what happens to asteroids when they collide with each other. So you probably started out with, much bigger asteroids, and then they crashed to each other and broke into smaller, and crashed to each other and broke into smaller. We see families of asteroids that share like very similar chemical characteristics. So they were once part of a larger object that had been broken up multiple times. And the universe is just, or the solar system is just grinding them all down into dust. Dougal, relative to the speed of light, how fast is the solar wind? It's not very fast. Solar wind is like 100 kilometers per second to, I think, 800 kilometers per second. I think the fast solar wind goes 800 kilometers per second. So what is that? That's less than 1% the speed of light. No, way less. Like 0.1% of the speed of light. WCO3, is there going to be a telescope in the future that will be able to direct image small planets around a G-type star? Yeah, I would say so. So the Habitable Worlds Observatory is going to be designed to observe worlds orbiting around stars like our sun. And so they are, and then, so like that's probably in the 40s, 2040s, probably. We might get lucky with the extremely large telescope, which is a ground-based telescope that's being built right now. Should be done in about 2 years, 3 years from now. And it should be able to directly observe Earth-sized worlds orbiting around sun-like stars. When you see a G-type star, that's a sun-like star. And then the other, but really close, and only in sort of specific conditions. And then the other one is called the Large Interferometer for Exoplanets. And this is the European Space Agency's version of the Habitable Worlds Observatory. And same kind of time frame in the 2040s, probably. It'll probably be a constellation of telescopes that are flying together, trying to observe worlds. So, right now we don't have the capability, but I would say within 20 years, we will probably have a telescope that can do this. Master Pack, would Planet X technically be a dwarf planet due to being in the Kuiper Belt or the Oort cloud? So it all depends on the size of Planet 9. Like if it is Earth-sized or Uranus-sized, then it will be considered a planet because it will be the dominant object in its orbit. Yes, there's going to be lots of Kuiper Belt objects that are around in the same way there's a lot of Kuiper Belt objects that are around Neptune. But Neptune is the planet. It is the dominant object in its area, while Pluto is just one larger version of a Kuiper Belt object. But there are lots of other objects around it that are roughly the same size as Pluto. So Eris is probably a little bit bigger than Pluto. Haumea, Makemake, they're all sort of in the same size class as Pluto. And so that's why Pluto got demoted to be a dwarf planet. If you believe the reasons from the International Astronomical Union, don't send me emails. I don't get a vote on this. But Planet 9 is expected to be large, Earth-sized, maybe even Neptune-sized. So it will absolutely be considered a planet if it exists. Alan Works, is there any possible way to scientifically move a planet? Yeah, theoretically, you can use an asteroid. So, when an asteroid flies close to the Earth, we get a little bit of a tug of its gravity, and that slightly changes the orbit of the Earth. And so if you wanted to move the Earth, and sort of the classic example of this is if, the sun is heating up, it's giving off more and more illumination every year. It's going to be heating up planet Earth. In about 1 billion years, it's going to boil the oceans on the planet. So you want to be able to move the Earth outward a little bit every year to match the energy output of the sun. And so if you bring one asteroid relatively close to the Earth every, I don't know, it's like 10,000 years or so, then you can slowly move the Earth's orbit out at a rate that matches the increasing illumination from the sun. So you do it with asteroids. This Aussie says, how can backyard telescopes give us better images? Riddle me that. Backyard telescopes are not giving you better images. So this is, again, people making stuff up. The very, very best backyard telescopes. There are some people with some really fancy, wonderful backyard telescopes, and they are maybe able to see the comet, maybe able to see a little tiny tail, or were able to see it before it went behind the sun, but it is nothing compared to the Hubble Space Telescope, James Webb, or the Gemini telescope. Like the Gemini telescope pictures were some of the best ones. That is a telescope that is 8.4 meters across. It is a ridiculously big telescope. It has an adaptive optic system. There's no way that a backyard observer. So instead, the backyard observers are in many cases making stuff up. And the ones who are legitimately showing you images that they're taking, they're just dots in the sky. Maybe a little bit of a tail. They're not doing any spectroscopy on the tail the way they're doing with Webb and Hubble and the Gemini telescope. Tommy's Woodpile Adventures and Tall Tales. Love your name. Do we have a Voyager-type mission to interstellar space today? Yeah, we have the Voyagers. So the Voyagers are still moving out in through the cosmos. And, even though it takes 24 hours for their signals to get back home, they have left the one portion of the solar system. They're now outside of the heliosphere, and they're now in the sort of combined solar wind of interstellar space. So yeah, I think a Voyager-like mission that qualifies for what you're talking about are the Voyagers. Now, are there any plans to build any more missions? And so the answer is maybe. NASA is working on a mission concept called the Interstellar Probe. And so this would be a mission that would fly out into interstellar space. And by that, we just mean like outside of the heliosphere, like where the solar wind dominates, and into the sort of interstellar regions where the solar wind, but have the right instruments. So it wouldn't, the Voyagers were designed to do flybys of Jupiter and Saturn. And then they realized they could also add Uranus and Neptune for Voyager 2. But this would be a spacecraft that maybe doesn't even have cameras on board. It would just fly really quickly out into interstellar space, and then would just start to sample the solar wind from other stars, because these are other stars that are sending material towards us. And so if we just go out there and we collect it, measure the magnetic fields and measure the composition of that, we could learn a lot about other stars and just about the composition of the Milky Way entirely. Computer hacker, if we go back to the moon to stay, should the Department of Transportation become responsible for space transportation between the Earth and the moon? I don't know. I mean, it all depends on how it works. Like, is only NASA is only the United States the ones going to the moon, or do you have an international collaboration of people going to the moon? So, probably the FAA, right? Like, who handles space travel? The FAA. So that would be my guess, is that it'll be part of the, in the same way that the airlines work. Is that under the Department of Transportation? I guess so. Thomas Kingston, I read somewhere that we've observed as much information from the CMB as is possible. Can you explain this? Kind of. I'm not the right person to explain this. My guess is either you heard this from Dr. Paul Sutter, or it was a conversation that there was an interview that I had with Dr. Paul Sutter like maybe 10 years ago. And so that the cosmic microwave background radiation, right? This is this leftover, light from the Big Bang, and it was released when the universe had cooled down to the point that it was transparent, and you had this last scattering. All this light was released out into the universe, and it was first detected back in the 60s with the Big Ear telescope, and it was really just like, oh, we've detected this radiation that is everywhere, and everywhere we look, and we try to remove the pigeon poop from our telescope, our radio telescope, and we still detect it. And they confirmed the existence of the Big Bang. And then there was people realized that the best place to observe this was going to be from space. And so they launched the Kobe mission. And the Kobe was able to detect temperature variations in the cosmic microwave background radiation, kind of confirming this idea that you would have these regions of higher temperature and lower temperature that matched regions of higher and lower density in the universe. And then you got the WMAP mission, which did a much better job of that. And then most recently you got the Planck mission, that took the most sensitive sort of measurements of the temperature of the anisotropies of the cosmic microwave background radiation. And so the idea is always like, well, could you just send another one? And the thing that I think you're talking about, and this is something that astronomers have told me as well, is that we've reached the practical limit of what can be measured in the cosmic microwave background, specifically the temperature, that the measurements that have been made now are as accurate as they can be. There's still lots of other information that you would want to be looking at in the cosmic microwave background radiation. You want to be measuring the polarization of the light. You want to be measuring the existence of magnetic fields in the cosmic microwave background radiation, but specifically the anisotropies. And I forget the technical term for this. It's not coming to me right now. I apologize. Maybe someone in the chat can throw in the term. Backscattering? No. Anyway, I forget. So, and I wish I could easily find the interview, because I literally sat and chatted with Dr. Paul Sutter about that several years ago. We were in Iceland, so the conversation is us in Iceland sitting around a table talking about this idea that we can no longer find any information out of the cosmic microwave background radiation. And I apologize. Modosir Ali, is it true that light doesn't experience time? Yeah. Like, what does it mean to say what light experiences, right? Light is not conscious, but if you could move through the universe at the speed that a photon moves, then you would not experience any time. That you would be emitted and you would be absorbed at your destination, and from your perspective, no time would have elapsed. And that's just how, like, if you just punch in Einstein's relativity equations, you calculate the amount of time, the time dilation that gets experienced, but you put the speed of light in for the speed that you're going, then time goes to zero. And then if you go faster than the speed of light, then time goes backwards. Figure that out. Alan Works. Are there any plans to do tests on asteroid 2025 PN7 since it's so close to us? Not that I know of. I haven't heard of anybody planning any missions to explore it. We have a bunch of quasi moons that show up every now and then, and they're essentially just asteroids. Now, this one has a very low speed relative to us. And so you could send a mission over to explore it and not require a lot of fuel, which is great. But I don't know of anybody who's doing it. Like, there's too many. It's like it's a target. The universe is a target-rich environment. It's the problem. Too soon. What animal would handle being in 0G the best? Handle being in zero gravity the best. I don't know if there's any animal like many animals have been to space. And in general, the simpler the animal, the more natural it is in space. You think about water bears, nematodes, they can handle being in space, while larger animals, spiders, have a hard time figuring out how to make a web. Birds, frogs, mice, things like that. People gets harder, right? I'm sure elephants would have a really hard time being in space. So yeah, the smaller and the simpler. Amoeba would be, would handle being in 0G pretty well. Which I guess why in Star Trek, right? The amoeba was the big alien. Robert Gavir, we are likely awash in interstellar friends visiting our neighborhood. Yeah, I mean, now that we have 3 examples of interstellar objects moving through the solar system, that allows us to do some calculations about how many of them there are, right? These were only discovered because the tools to discover asteroids have finally gotten good enough to be able to watch and find objects like this. And so you will, as better tools are made, like when Vera Rubin comes online, I always say this, like, now I can't wait to say, like, now that Vera Rubin is online, or, in recent studies from Vera Rubin, but right now we're still in the pre-Vera Rubin coming online phase. Then, it's estimated that there are probably tens of thousands of interstellar objects moving through the solar system right now. Now, most of them are really far away, too far to observe. But every now and then, probably 10 to 12 will be found moving through, the more central part of the solar system. And this was happening all along, and we just didn't know. And now we finally have the tools to know. We were able to open our eyes and see what's really happening with the cosmos. P. Dibs, would gravity tear a Dyson sphere apart or solar winds? No, there's no reason that either of those would tear a Dyson sphere apart. Now, like, the thing that's really important to know is that a Dyson sphere is not like an actual rigid sphere that is, being held around a star, that it is going to be constellations of satellites that are moving in orbits. And so, you've removed all of the planets in the solar system. And so now you don't have to worry about any gravitational interactions. There's just the sun and then all of these satellites that are buzzing around. And then the solar wind is definitely a constant pressure, and it will like slowly try to push satellites away, but they'll have propulsion systems that will allow them to compensate. So no. Eric Fawcett, how old are the oldest visible craters on the moon? Billions of years old. I mean, because there is no erosion on the surface of the moon, the craters that we see, some of them were formed just like a few 100 million years after the moon itself formed. The South Pole Aitken Basin, is the largest crater on the moon. It's huge, like 1,000 kilometers across, and formed very early on during the late heavy bombardment phase of the solar system, which was really only a few, within a few 100 million years of when the moon itself formed. So we see craters on the moon, especially the big craters on the moon, pretty much right back to its formation. The X-Borg, do you think quasars have a habitable zone or space for rogue planets in interstellar space? So quasars are actively feeding supermassive black holes, and so they're going to have, right, you've got the, the black hole, and then you've got all the material that's falling into the black hole, like maybe it consumed a star, or maybe it's colliding with another galaxy, and a lot of material is finding its way down around the black hole, and you get this accretion disk around the black hole. And then the black hole is spinning, and you get magnetic fields that are sort of twisting and turning around the black hole, and it creates these jets that appear above and below the black hole. And if we can see the jet, now not directly looking at us, like if it's directly looking at us, it's a blazar, but it's like if it's a little off, then we see that as a quasar. And so it's putting out an enormous amount of radiation, but specifically it's got that accretion disk that is putting out a ton of radiation. And so that is a source of energy. And so theoretically, there will be a habitable zone around a quasar where the amount of radiation that is coming off of the accretion disk around the black hole is enough to have a planet be able to have liquid water on its surface. And so, yeah, it might not be very stable for planets. Like it's a mess around there, but maybe you could have rogue, as you said, rogue planets are moving through the area and they've got liquid water on the surface, and they're being put to that temperature. They're heated up by the quasar, by the intense radiation coming off of the quasar in a way that makes them habitable briefly. But the problem is that quasars don't last for very long. There's a time when the black hole is feeding, and then it's putting out the amount of energy, but then it's feeding a little bit less, so it's putting out less energy. There's times when they're quiescent, they're not putting out anything. And so you need something that is the same amount of energy output for hundreds of millions, billions of years for you to be able to have life form. And with a quasar, we still don't know exactly how long quasars last. What is the active feeding time frame? But we're starting to see examples of quasars essentially turning off or turning on. And so after a while, we'll get a sense, but it is in the probably millions of years to hundreds of thousands of years, maybe even thousands of years time frame from quiescent to active. Which exoplanet is the closest? It would probably be the exoplanet around Proxima Centauri. So Proxima Centauri B would be the closest exoplanet that we know of. 4.2, 4.3 light years away. Very close. Sorek 311, will we ever penetrate Uranus's atmosphere? So with the missions that were sent to Jupiter and Saturn, they included an atmosphere probe, one that was dropped directly into the atmosphere. Actually, no, sorry. With Jupiter, they had the Galileo mission had an atmospheric probe on board, and so when Galileo arrived at Jupiter, it dropped the probe into the atmosphere. The Cassini spacecraft, when it arrived at Saturn, it was the atmospheric probe. It crashed into the atmosphere of Saturn and was able to provide a little bit of data before it burned up. So you would assume that if you were going to, if a mission actually went to Uranus, they would drop a probe into the atmosphere, or Neptune. We still don't know. Like, it would be really useful to know about the upper layers of the cloud decks of those ice giant worlds. Um, 9A4GE Millen. Can Comet C2025A6 Lemon produce a new meteor shower? So, like, all comets are leaving debris behind them as they go around the sun. And so the debris tails are what we experience as meteor showers. When the Earth passes through the tail of a comet, that the comet has left behind, then we see the meteor shower. And so the trick is that the trail that the comet is leaving has to cross the orbit of the Earth. And I don't think A6 Lemon is going to be an Earth crossing comet. So there aren't a lot. We have like maybe 12 major meteor showers every year from various, like mostly comets and one asteroid that actually cross the orbit of the Earth. So that's the thing that you need. So if you could have a planet get out there and pass through the tail of Comet Lemon, then you would absolutely get a meteor shower. All right. Time for like one more question. Todd Ablet, would you rather spend a week in orbit or a week on the moon? Assuming both are safe enough for commercial travel. Oh, I would want to spend a week on the moon. That would be very cool. Yeah. Yeah, if I had to choose. Like being in orbit would be really amazing, briefly. You'd be like, I'm in orbit. Look at that. I'm looking at the world. This is incredible. I'm in space. And you look out the window. This is great. And then, then you see the same, like this again. But on the moon, it's a totally alien landscape. And you can walk around and explore. You can pick up rocks. You can jump around in the 1/3 gravity. Yeah, I would, if I had to pick one, I would prefer going to the moon. Brooklyn Graham, is there any way to simplify the moon landing so that it doesn't involve such a huge elliptical orbit? It seems almost too complex at the moment. So you have to, like, if you want to go to the moon, you have to follow an elliptical orbit. Like, this is how orbits work, is that the moon is going, in an orbit around the Earth. And so you launch off the Earth and you have to pretty much chase down the moon. You climb out of the Earth's gravity well and get to the moon. And then you fire your rockets and you go into an orbit around the moon. And so, like, if you tried to go, like, just straight at the moon, then you wouldn't be able to slow down to be able to go into orbit around the moon. And so, yeah, you have to follow this fairly gently. You have to follow this fairly gentle trajectory to get to the moon. So then you can fire thrusters. You can go to orbit around the moon. And that's just like how orbital mechanics work. And it sort of, a lot of it's very unintuitive. That, I highly recommend playing a video game like Kerbal Space Program. Although it's, they're no longer updating it, but still you can play the game and you learn a ton about orbits, about how this whole thing works. And I learned more about space exploration and orbits playing Kerbal Space Program than I did in my work as a space journalist. Okay. All right. I think we've reached the end of our time together. So thank you, everybody, for hanging out with me. Hopefully this time worked very well for those of you in Asia and those of you, I guess, in Europe in the morning, and those of you maniacs that are on the East Coast and it's 3 a.m. It's always super fun. Thank you so much, Zapfan, for sticking around and categorizing questions. So what's coming up? So tomorrow we've got Astronomy Cast at 11 a.m. Pacific, and I don't know what the topic is, but it'll always be fun. So definitely go and check out Astronomy Cast. That's the long-running podcast that I do with Dr. Pamela Gay, astronomer Dr. Pamela Gay. I'll probably have a new interview that we're going to post tomorrow. I've got like 3 of them in the can right now. This one's a good one, if I remember correctly. Yeah. And then it's the week continues. So, thank you everyone for hanging out. thanks in advance, Chad and Anton. I have to deal with this nonsense that we just created. And we will see all of you next week. Next week's going to be 5 p.m. Pacific time. So just keep that in mind.